السلام عليكم. ازيكم عاملين ايه؟ Welcome back to our latest session. It is going to be with Ahmed Adel Ismail. It is going to be about multi-platform app design with Kotlin Multiplatform and Compose. So let's first welcome Ahmed Adel. It was a very long time since we saw him, and we do have a new session, and it's going to be presented in English by Ahmed Adel. So Ahmed Adel, the floor is yours.
Thank you. First of all, today's session we are going to go through the thought process of how we can start make an application mainly that serves on Kotlin multi-platform and Compose in the majority of its code. We will start with slides showcasing what are the requirements, the function requirements, and the non-function requirements. And then we will go through the process of how we can take the decisions for making this application. And after that, we will walk through the code. The repository is already there, and its link is there, and it's public on my profile on GitHub. We walk through the code on the parts that matters. And also, we will showcase some tips and some ideas. Not all of what will be here will be standard. It will just be ideas, thoughts that we will share together. Some of them may be of beneficial to you, some of them maybe not. So I think we can start going through the slides now. Let me. I won't share the screen. Yes. So now I hope the slides are visible.
It is.
Is it visible?
Yes.
Okay, fine.
Yes.
Fine. So in today's session, what we'll do is, as I said, we'll walk through the process of writing a KMP application, receiving the requirements, and doing everything till we start implementing the features. And as I said, it's all about the thought process, not about the code itself. So our application here is its function requirements. Function requirements means the business requirements or the requirements that makes the application functional. It has 4 bullet points, which are that users do log into the app, and then they can list all GitHub repositories, and then they can add or remove any of these repositories to the favorite repositories, and then they can show a list of all of these favorite repositories. Just a point to mention here, for the sake of this POC, all the data is mocked, so we are just mocking one class that is giving us fake data, which is then can be replaced with the actual data, and this is the only point that is that needs to be replaced in the code, but everything else is technically functional and just needs some UI nits or some adjustments that's not that major. So the first thing we do when we take these requirements is to start identifying the use cases of our project or this application. Use cases or scenarios are spotted by the verbs in these requirements. Like, for example, here we need the user to log in to the application. So we need to have a scenario for logging this user. Also, we need to list all the GitHub repositories. So we need to have a scenario in our application to list all of these repositories, GitHub repositories. And we have add or remove repositories from favorites. So these are 2 other scenarios or use cases that we have: adding repository to favorites and removing repositories from favorites, and listing all the favorite repositories. And this is another scenario since we have different things to show here. The next step is to define our domain models or the entities. And these are defined by the nouns in these requirements. Of course, not all nouns, but we take an idea of what should we model in our application. Like for example, users log into the app, so we have a user. So this seems to be a domain model. By the way, all of this is the initial the decisions, and this can be changed in the future. But we initially start spotting our domain from this kind of stuff. Then we are listing a GitHub repository. So we should have a domain model that is called a GitHub repository. And by the way, in this session, we want to go through a Figma designs, but normally we would have a Figma design or whatever to identify for us for the mobile side what are the parameters in these domain models. Like GitHub repository, we should see in the design what are the parameters that needs to be displayed on the UI, and then we define this GitHub repository with these data. Like if I need to display a name, a picture, number of stars, so I have to define my GitHub repository model that contains a repository name, a repository picture, and a repository count of stars, whatever. Also, we can add or remove a favorite repositories. Here, I took a decision to make the difference between GitHub repositories and favorite repositories. Others can say no, the favorite repositories are also the same, they can be the same domain model. But I believe that when we divide the application, the next step we'll see that the favorites will have its own features, so it may be different in design than the GitHub repository. So this is one of the many approaches that we can do. So one of the approaches that I've chosen is to divide, to not make them both as the same thing. Now defining the features in this application based on the use cases and the domain models that we have found. So we can see that we have a login feature, which is its scenario is to log in a user, and the user is its domain model. Also, we have the main feature. It can be called the GitHub repositories feature. And just I called it here the home or the main, since this is the home screen of the application, which has three use cases, which is the list all, the add, and the remove. And they all deal with one domain model, which is the GitHub repository. And we have a favorites feature, which has one use case, which is the list, and the domain model, which is the favorites repositories. So this is about the functional requirements. What about the non-functional requirements? And this is some example of the non-functional requirements of this small project. Like one of the main non-functional requirements, and this is the reason why we are using KMP or Kotlin Multiplatform here, is the portability. Is that it's required that this application must run on Android and iOS and desktop with minimal changes. So this should be this is the reason why we're using KMP. Also, one example, non-functional requirements in security. For example, that the login validations are dynamic. They must be fetched from servers, so they are not hard-coded in the app. So why this non-functional requirement is here? Because when we go to the code, this also can result in extra use cases or extra domain models that we see because of non-functional requirements. We don't just spot our use cases and domain models from the functional requirements, but also non-functional requirements can play a role in adding more code or modifying our code. Also, we have a non-functional requirement, which is the scalability, that the app must be open to adding new features easily with no extra cost. And this is to specify that this app needs to be divided in a way that multiple people will work on, and multiple features will be added, and we don't need tight coupling in it, as this is the vision of this project. So we know from the beginning that this will be a cost, is to modularize this application. It's not just an application, just a POC to make it for once and leave it. No, it will be modified and add new features later. So this needs to be considered. So based on the non-functional and the functional requirements, we need to put the initial architecture of this app. And this means that we need to take the important decisions that are hard to change in the future. So as we decided that all features will be written in Kotlin Multiplatform and Compose, since it's on 3 platforms. Each initial feature will consist of a hexagon or ports and adapters. And this is because the nature of this architecture requires that the ports, or the heart of this architecture, the core of it, is in a pure language with no external dependencies. So following this architecture, as we will see later on, helps the Kotlin multi-platform to write all the code that matters in KMP code and leave the external parts to non-KMP code, which comes to Compose, and this is the power of Compose, which completes this missing part, as we will see when it comes to the UI. And the only part that we will have to implement natively is the data sources implementations, as we will see in this project. We have also one of the decisions that we make is, since we have a scalability in the non-functional requirements, so we need to put a rule for this, that no feature will depend on another feature, which means that the login feature should not depend on the home feature, and the home feature should not depend on the favorites feature. And this is why this is to decouple the application to make it more scalable. So in this phase, when we are trying to put the hard decisions that will, the initial decisions that will be hard to change in the future, this is the kind of decisions that we make, the kind of rules that we put, so that when people start to work, they don't block the project for future updates or future changes, and also they know the vision of the project when they are working. Also, we limit native code to data sources layer and parts of the UI layer if required in some edge cases. And as you will see in this project, Kotlin data sources layer was the only part that needed to be in the native code, and in nearly the persistence part, even the server side, we could have used Ktor. Navigation and dependency injection will be implemented in a top-down manner, which means that the application entry point in KMP, or which is similar to the application class in Android, will be responsible for navigation or handling the navigation and dependency injection. This means that, for example, when and this is happening right now, that the navigation library for Compose started to being supported, we don't want to pass the navigation host for the composables down there. We need to limit the logic of the navigation into one place of the application, which can see everything, and this we will come to in the code. Same applies to dependency injection. And since it's known that the navigation library and the Android view models are on their way to be supported by KMP, any investment in these alternatives of this area should be considered a technical debt, which means that we are planning here the technical debt in our project, and we know when exactly we should stop and start fixing this problem. Like we anticipate that there is a navigation library coming to KMP, and we anticipate that the view models are coming completely. It's partially supported now, but it will be coming completely to KMP in the future. So from the beginning of our app, we know that we have a technical debt, which that this code from day one will be considered deprecated. And once we have these technologies out, once we have these libraries gone in a stable version, we should switch to them. And by this matters when we are starting to develop our code, to make sure that any code regarding these two should be in a way that easily replaced with these libraries when it's released. And one last thing, we start putting the rules that teams should respect while they are doing their PRs, for example. One of them is the KISS, or keep it simple and stupid, which means that this is our main rule. So, for example, if one engineer have pushed the code with a fancy solution for a problem that have a simple one-liner solution or 2 lines of solution, in this review should not be should be considered to highlight that this is a problem. Why? Not because he has done bad thing, but because we accept as a team that our rule is we start as simple as possible, and we start introducing fancy and complicated stuff when things get complicated, not the other way around. And I'm putting this line here is to showcase that such kinds of rules are done into this phase initially, so that when the team starts working, we know what exactly to put in. For example, the linting, when put in Sonar or in any in the PR reviews or the Git hooks or whatever. Now going to the application architecture itself. In the application architecture, this is the translation of what we just mentioned before. We have an application entry point which is responsible for the navigation and the dependency injection. And this application depends on four features. Actually, the login feature, the home feature, the favorites feature, and we have a component that represents the navigation. This component is some kind of a first party library. So we deal with it the same way we deal with other features. We have three features, and we can call it an SDK of navigation, or a first party library navigation. And we decide here that navigation will internally work with also ports and adapters architecture, similar to all the other features. By the way, in general, we decide that for the initial features will run in this architecture, but this is not a must. Like in the future, whenever we could get another feature, we can choose a different architecture. But these decisions were made based on the information available in our hands right now. So application navigation depends on the features. Each feature internally have its ports, and these ports are pure code, pure Kotlin code that doesn't depend on any external dependency. And the adapters part, which can depend on external dependencies, like if you have common code like common adapters, or if you have data sources code, if you have any third parties, these are communicated with from the adapters code, not from the ports code. So, and one hint here, if you find that you are able to describe or put your UMLs for your architecture in an easy, visible way, know that your architecture is simple and to the point. If you find that there are too many arrows going right and left and up and down, know that there is something needs enhancements in your architecture. So try to evaluate your decision making by evaluating how the diagrams that you are putting out do look like. Are they simple and readable, or do they need enhancements? Because if they are not simple and readable, you either need to find a way to make them simple and readable, or they won't be simple and readable because they are not simple and they are not to the point from the beginning. So there is some kind of a mistake there that needs to be fixed. So this is one thing that we think about when we are putting the architecture of the project. Again, this session is about the thought process, how we think, how we process the requirements and convert them into a real project. Now going to break down each feature, we decided that the feature will be a hexagon or a ports and adapters. So internally, this is how the features will look like. At the below here, we have the feature. The architecture is divided into two modules or packages or whatever, two components. The first is the adapters, and these adapters depend on the ports. The ports module doesn't have, by the way, module or package or whatever, doesn't matter what it will be translated into code, but again, this is an isolated component at the end. So the ports consists of domain models, these are data classes, and scenarios, use cases, which are functions or functional classes. And whenever these scenarios trying to execute something, they will need to domain models, plus they need some sort of things from the external world. And here comes the ports. Like if the scenario need to update something on the UI, we need a UI port, which is UI state port. And this UI state port has an interface that represents the UI state where the scenario or the use case modifies to show its results. And the data sources port represents the interface which, whenever our use case or scenario needs something from the data layer, so we declare this interface and its methods here, and the use case depends on this data source port and start using its method, invoking its methods, which will later on be implemented to get things from real data sources. And in all of this ports package, which contains of the core and the ports interfaces, does not depend on anything else outside them. So all of their classes in their import statements, they should not show anything but their core statement, their core import statements, which technically no import statements at all. And then we have the adapters part, which depends on this core, and the adapters is the place where the real code happens. So we have the implementation of the ports interfaces, like we have a data source implementation. This implements the data sources port. And actually, this depends on the external dependency of the data sources module that grabs the data from it. And also, we can have in this adapters the data sources models mappers, or the factory, if we are talking in a domain-driven design language, the factories for the domain models. So in the adapters, we have the visibility for the data sources. We can use them. We can map things from and to them when we are trying to implement the data sources ports. Also, we implement the UI state ports. So we implement the UI if our view model, for example, if you are using view models, should be the UI state implementer at this diagram. So we have a view model that implements the UI state port. Since the view model will show the UI state, it will hold the UI state. And another part I've added here is the UI composables, which should not be part of the adapters, but part of the feature. But it belongs to the same section where we are drawing the UI composables at this part as well. So actually, the UI composables is driving all of this. The UI composables is injecting all of these other adapters in the form of their interfaces. They depend on their interfaces, and then it's using these interfaces, and all of the injection of these things happens at runtime. And the last thing is that adapters, if you need to do any dependency on any external data dependency or any common code, it happens on the adapters level. So the ports are safe. And this is where this helps in the KMP, because since the ports which holds our domain, holds our domain models and use cases and UI state and the data sources declarations, all of this is KMP. And then we'll come to the implementations. We are implementing this also in Kotlin and writing the UI in Compose. We are nearly having 90% plus of our code in common code. We don't need any native code in all of these stages. The only stage that we need a common native code is about implementing the data sources libraries, like implementing persistence or implementing database if we had to, if we don't use SQLite, for example, or implementing whatever. So let's walk through the app. And by the way, this is from the current GitHub repository here. If you see the Kotlin code, Kotlin percentage is 99.1%. And this application is currently working on Android and iOS and desktop. So moving on to the code itself. Actually, if you look, this is the KMP project that's created. We created through a wizard. I won't go through the implementation details of how we create a project and that stuff. It's on Google, and I think it's easy to access. But the important part we need to mention here is that here is the code for the platforms that we care about in this module. So this is the main activity for Android, and this is for the desktop. This is the main function for the desktop application. If you see, this is the only code for the desktop application, nothing else. And this is the iOS code, and this is the only code for the iOS, nothing else. In the Android, we just, since there is a back press, so we need to handle this back handler. It's out of the scope, but again, like it's a three lines modification specific for Android, just to handle the back press. So it's out of our scope here. Again, since we mentioned that the navigation part, the navigation implementation itself, is also will be provided by Kotlin Multiplatform in the future. I think they'll support the navigation, Android navigation library here. So we just made some sort of a logic that handles the navigation. If you go through it in a fast manner, this is the navigation module, and it has here this business logic for to check if the user is logged in or not, and if it's logged in, it will turn the home screen, and it will turn the login screen. We have here declare the screens here as if we declare it in the navigation components, and these are the statement. This is how we hold on to the navigation, the current screen and the current view model, since we don't support view models yet here, so it maintained manually. And all of this is a tech debt. It's not part of the scope, and it will be provided out of the box in the future, so it's not a big deal, but the code is there, whoever wants to look into it. So what matters here is that what happens in the application class, or the entry point, is that it initializes the Compose theme, and then we start holding the state for the navigation, and we'll start launching the business logic for the navigation to check for the user if he is initialized or not. By the way, The initial state is the splash screen, which doesn't deserve as a feature. It's just a static screen. So the initial state of our navigation is the splash screen, and then this business logic will trigger, will return for us the next screen to navigate into. So just to give a hint, what's happening here? This is one statement checks for the next screen. Like for example, if I'm in the login screen, when the use case returns to the navigation component and tells it now go for the login screen. So here this is similar to the dependency injection part, where it grabs the view model. This is similar to the view model, and then gives it to the composable function here. And then in the composable function, instead of passing the navigation host and in the function of login, tell them to where to go, we just give back the callback for the on success. So that here in the navigation logic, we mention that I will navigate to home. So this with the navigation components will be just trigger the navigation to home. Here, since we are doing this manually, we are changing the screen to the home screen, which will again get into here and get into this one statement, which will inject the dependencies to the home screen here in the composable. And in the home screen, when we click on the favorites, it will navigate to favorites and so on. So we don't pass the navigation down to each component composable. And this is one thing that's worth mentioning about what we're doing here, because it's not the responsibility of the composables from the inside to know about something called navigation host, or to tell about the commands to this navigation host library about what to do. But instead, they should provide a callbacks, and here in this point of the application, this should see all of the navigation hierarchy. It's possible to pass from whatever screen to whatever other screen in the navigation components or whatever. So the navigation logic comes from this point. Also, the dependency injection comes from this point. Also, I don't want to go through this because this is simulating the view model behavior of Android. So once it's there, we won't need to do this kind of stuff again. So this is about how we will navigate into the project. So now let's start with the first feature that we have here, which is the login feature. So if you see here the login feature, I want to just focus the package. Yes, I want the packages to be focused here. So if you see, as we said, for each feature, we will have it in hexagon. So we will have this the adapters, and we'll have this package which will hold the core and the ports and the core, which is the domain models, the scenarios, and the port interfaces. So what exactly we are doing here? First thing, we go to declare the business logic of this login. So what we have in this business logic, we have the login scenario. So this is the login scenario. So what we need to do, and this is I'm trying to showcase the thought process of this. What we need to do in the login, we need to first, when the user hits on login, we need to make a progress. First, show the progress, and then we need to validate, which this was the non-functional requirement that had to get the validations from the external dependency. And since we are validating from an external dependency, we need to have a data sources interface that has a method called get username validation, get password validation. And after we validate, we need to go to the data sources and tell them to log in and expect them to return a user. And after we have a user, we need to go for the data sources again and tell them to save the user. And once happened, we need to navigate back to the external world to show our success. So we will have some sort of a variable of result that is showing success or error, and we need to show the progress. So we define here the UI points and the data sources points that we need to communicate with. So we need to communicate with the progress, we need to communicate with the username and password to take the input in. So we declare the first thing, the UI port, which is an interface that will be implemented by the view model or the UI state. And here we decided to go for an MVVM similar fashion, where every piece on the UI has its own variable, but we can go for an MVI fashion or pattern where we have just one data class that represents all the UI state and success and failure or whatever. So this is an implementation detail. It's not. It will work in both ways. So in my login state, I declare the things that I think that whatever UI needs to deal with me needs to implement. So the view model needs to have a progress, needs to have a username that holds a string, a password that holds a string, and a result. And also it needs to provide me a data sources port to deal with data sources. Here the approach here we injected it through the data port, this interface. That this interface should see the other interface to give it to the use cases, but this has multiple ways to be done. So if we go for another port here, which is the data sources, this is the interface for any external dependency that's dealing with data layer now. So we need from it to declare a method that gets the user's name validations, a list of predicates or functions that return booleans. Also, some validations for the passwords. Usually these are regexes, but I'm just putting it here for simplicity. And the login, we need to communicate with a data source from whatever server or Firebase or whatever, a library, SDK, and ask it to log in for this username and password. And this should return the user with all of their details to save it. And here we need to save this user, which let us know that this is saved. Of course, in the more real life world, we have to handle the tokens and refreshing of these tokens and all of this authentication stuff. But this is just for the simplicity of this application. So now we have declared our ports, and we have declared our use cases that are using these ports, which is this. The login is an extension function on our login state UI port, and we are currently, whenever the login operation happens, it can easily control or manipulate the UI and trigger whatever it needs from the data ports and return what it needs to the UI again as well. So this is the use case, and these are the ports. Now we come to the adapters. By the way, this is the domain model that we have, which is the user, and we'll come to the metadata later on about what this is about. So this is the domain model, and this is the use case, and these are the ports. Now we come to the adapters who implement these things. So for the login data source, all we need to do is just inject. In this project, these data sources class is this data sources is an interface that holds all the operations with data sources outside the project, including the login, the getting or repositories, adding to favorites, whatever, any function that deals with the external world is declared in this interface. And this, when we are talking about KMP, this should be an expect class. And this expect class will have all of this as expect methods, and they need to be implemented on each platform. So this is the only part where we will go to the native code in the implementation of this data sources interface. In more scalable projects, we could divide this like the authentication data sources alone, the GitHub repositories data sources alone, or whatever. The point is, this is declared in a domain, in a data module. So this data module actually should declare in a real life scenario, should declare this as an expect, and we will be forced to provide the actual implementations in each platform. And this is the only point that needs the native code. But here, for the sake of mocking, we are mocking this to in-memory cache for the application to work. So this is the implementation, which should be available on each platform by their own implementation. But here we are providing it and using an in-memory cache to cache the data instead of putting it in a database or whatever. So this data package is the only package that will contain an expect classes and an actual classes on other platforms. And it's scoped to this part just like this. So back to the login data sources, it needs to depend on this data sources interface and inject at real time. By the way, Kotlin has this beautiful feature of default parameters. So you can inject it here and still go to do your unit testing or whatever, and this will not be a problem with your graph, dependency graph. So it injects the actual code here and start using it, delegating its problems. And if there's any mapping, it happens in this implementer for this data source port. Like, for example, here we are getting the login method. When we are communicating the data sources, the data sources returns a user DTO. This is not our domain object. This is not our user in the domain of the login or the feature of the login. So in this phase where we are implementing this method of the data sources, we can do the mapping, our mapping from and to the DTOs, since this is in the adapter and it depends on the data models. Um, it can see them. And in many cases where we need to share some data between multiple features, for example, or when we communicate with the backend, and then we get this user object, for example, this user data object that comes from the server, and we start say, okay, I need to use its analytics, but all what I need in my domain object is just an ID and a token. But I need the username, for example, or I need the whatever data here. Here, for example, I may need the email for this user in an analytics operation in the future. So instead of keeping myself tightly coupled with the user data, so my user object, all it cares about in my domain, in my feature, is caring about the data that it actually uses in my own feature. So if tomorrow someone comes and say we'll do an analytics and we will send the email of the users when the user logs in, from my feature, I won't need to change anything, but I will store this original POJO that's coming from the server into a variable of type any. And this is a trick, but it helps a lot in common models across the domains. So now for every domain model that I have, I can declare a metadata or a data or whatever I call it, which is a variable of type any. I don't depend on its type. And whenever this user is initialized from the server, I store the source object that comes from the server in this metadata. And I keep passing this user around my features. I keep passing this around my system from one class to the other or whatever. And then at some point, when I need, for example, to send an analytic or whatever, I go put the analytics trigger in another data source class, and then I pass to it this user or whatever. So I have the metadata. So if you see here in the factory that we are doing here, the mapping part, let's call it the mapping part. Here, when I'm creating this user, I put this user data into the metadata, and also when I get this metadata as a user data from this object at the end. So now, if, for example, I needed the email for this user to take it from one side to go to the data sources on another side to give them this email, I don't have to declare an email as a variable here. I have the original object. So all what I do is that when I go to communicate with the other side of the world, I will pass to them this object again. So I pass to them this user data again. So they have the full user data with all of its details, so they can use their email, they use their whatever. And we'll see this more clearly in the favorites part, because this will be more clear when we are moving the GitHub repository from the all GitHub repositories to the favorites repository, to the favorite repositories. So this will be clear at that point. But this is the metadata, and we'll come to it back later. So if you didn't get it that much, don't worry, we'll come to it again. So now we have implemented this data sources interface, and now we are implementing this UI state interface. And this is a nice part, because if you see in the interface, we are declaring just a variable of Boolean, variable of string, or whatever, just placeholders for the variables of the UI. But in KMP, it's easy to, since this username, for example, was declared as a string, I can use it as a mutable state of string and use this delegate to return a string, so it can override. So I can override a normal string in the interface to declare it as a mutable state of string, and the compiler will work, because this delegate converts this mutable state to a string. Same here, it will convert this mutable state to a Boolean, and so on. And this also skips another part. I don't now, since in my implementer, this view model class, I have declared my mutable states in this class. I don't need to declare it as a flow and then go and convert it as a state in the composables. So this is another. It's not a standard. It's just an idea about how to simplify things, so that all we need to do now is just override this interface and provide the mutable state of the same type of the interface types, and delegated by the use the delegate, so that it will be a normal strings and so on. So at compile time, it's the same, and we use with it the same. And now we need to link all of this together. So we go for the login screen. And the login screen, this is the entry point of login screen. So we don't inject the view model internally. We expect the view model to be coming from outside, which happened in the application code, in the application function. So it receives this view model implementation view model, which is the adapter that implements the login state. And it has an on-success callback, which navigates to the next screen. And this is the modifier that will be passed to the top composable to modify it. This is the sensible way, as recommended. And then the dispatcher, so that we can switch things to background if required, like, for example, processing the login and so on. And if you see here, these are composables. All of them are normal compose code, nothing special here. Let's just go through it. We have here the login content, and this login content consists of a user. Let me make it on Android here to build while you're looking at it. A user outline text field, and a username, and a password, and a login button. And here, whenever this login button, if you see, it will take an on login clicked, and it will execute it. So when we look into this login operation, here is, by the way, here is the application. So in the login button, when we pass the on login clicked here, it should perform the login.
We do have a single request. If you can increase the size of the font of the code, or just zoom a little bit.
The code is small, like this.
Yes, that's much better. Thank you.
Okay, fine. So again, like this is normally the composables that draws this UI on the left side. And if you see here, I have a validation, for example, for this username to must have an @ and this both must not be less than 4 digits. And then the login button. So here the progress happens and so on. So if you see this is how we design our composables. But there's a problem here. And the problem is, if you look at every composable here, see how many parameters are we passing around for just a very simple screen like the login screen. And this is, for me, this is a big problem. So I have a suggestion, which is not a standard, which is not official. Now we went to the home screen. So in the home screen, if you look at the home screen composables here, let me minimize increase the flow. Do you see here the home screen has only one, since all of the composables are private actually, so this is the case. So by the way, the home screen, we will apply the same things that happened in the ports and the adapters of the login screen. We can walk through it later, but this is one point that matters. The home screen here waits to be injected with a home state port, which is in fact also another interface that declares the progress and the repositories to be displayed and error and so on. And this is implemented the same way here, just putting here, injecting the data sources, the home data sources, and using a progress and error. And the repositories here is a mutable state list of, so that the daisy column or the recycler view, or daisy column or whatever, can detect which items are changed through this mutable state. So in the home screen, we take this port. This is the injected, and also we have only one navigation action, which is on favorites click. This one, the top right here. If you click on the top right here, it goes to this favorite screen. If you get back, it gets back to the home screen. And internal. So here, what see is we can benefit from scoped functions or the internal private functions. So now, for example, this is the top app bar. And I have here the on favorites click. This is an on click action. In the normal scenarios, if I declare this top up bar as a function outside this home screen function, I will have to pass to it the on favorites click so that it hits the on click button here. But since I am declared inside this home screen function, I can here declare a favorites icon button, and in this favorites icon button, an icon button in the on click, it can access this variable which was declared at the top level. So scoping down the function's declaration inside its composables, one nearly eliminates the parameters. That if you get back and look into these functions inside, do you see? Sorry, do you see here? I have in this home screen, I have a top bar content. I have the list items content, which is this one, and I have a favorites dialog because when I click on this, I need to add or remove or whatever. It has a protection so that it doesn't click on the progress. So here, for example, I can keep adding or whatever, and then this is the favorites dialog. And this favorites dialog is depending on a state outside. So the state is declared here actually. And so on. And this is the home screen content, which is gathering all of these composables together. And all I need is just invoke it. So if we go through this, we'll find that this home screen content, which is invoked here, is actually doing a launch effect to initialize. It's doing the list all use case, which lists all the GitHub repositories. And then it starts rendering the composables. It puts the top up bar. And if the state is progressing, it puts the linear progress that was there. Like if you come here and get back, you see this progress bar at the top. This is the state is progressing. And then it puts the list items content. I think this way we can, and that's it. And this is, if you start reading this, you'll find that it's much more concise, much more readable, with no much parameters going around, as you have all the parameters that you need here declared at the top level. Of course, it will be a mess if you declared all of them in one level. So that's why, like in the top up bar, the top up bar has this title and icon. So if you open the top up bar, you'll find that it's declaring the icon composable inside this top up bar. If I don't care about what's inside the top up bar, I just minimize this method. I don't see anything that's not on the level of the screen. And then I go for the list items content, which is this section of the screen. When I open it, I find three states of this, which is the error content, the empty content, and the loaded content. The empty content, which you see at the beginning of the application, but it's not. But anyway, what you said, no repository, it's similar to this one. This one, no favorites. This is the empty content. And then this is the real implementation here. So if I have an error in the view model, I show the error content. If my repositories are empty, I show the empty content. Else, I show the loaded content. So again, I'm not. The screen is not filled with many parameters and many non-related composables. If I don't care about this section, I minimize it, and then it's back to clean again. So let's continue about this. When I see the loaded content, also do you see it doesn't take any parameters? I open it, and then I have a lazy column which draws the items here, which is drawing directly from the view model repositories. So these are the items that are displayed in this lazy column, which are these ones. And it's putting by the key, and inside it, it's just calling this item content, which draws the item. And here, since this is not using any of the parameters that were passed here, it's using the item that will be passed in this lazy column. So at that point, I need to declare a parameter. So here we are declaring this is an actual required parameter for this function. It's not a parameter that keeps passed by from one to the other to just pass around. So this, instead of having many parameters, one for the error and one for whatever, it just have only one parameter, which is the item that will keep drawing to. And then this item, if you see, this is the item content, which is the content of this item. It starts showing us that we have the item image section, which is the section on the left, the item middle section, and the item stars section on the right. And as you see, we are not passing anything as a parameters because all of the values are stored inside this item, and we are declaring this inside this function, so we can see this item as well. And then this is the item section. We have this painter, so this is about loading the images. We have a library here. I use a library called Camel, I think, for fetching the images. Anyways, so looking into the actual rendering of this item, so it first renders the item image section, and then the middle section, which gets the names. So here, this is the item middle section, a text with repository name, a text with repository owner, and then the item stars section, which is actually, we needed to make a star icon, so it's declared inside this function. And then we do our logic of rendering this star section here based on if there's a progress. As you see here, if I add, this progress will appear. So there's a progress, and once I finish, it shows the stars icon again, and so on. So what matters for me about this section of the code is how we can eliminate the noise. If you look into the login screen, how many parameters passed around into private functions even. This is just to show the username outline, and this is the password outline text field, and this is the login button. If you see how many parameters going around just for username, password, progress, result, or whatever, yes, like we need to hoist, but I think the hoisting has happened at this level. We don't need to keep nested hoisting for all these composables again and again and again, and the compiler is smart enough to detect the changes. And as we are holding our states in the view model, we don't need to care even about the states. Like this is one of the states that we need to hold inside here, because this is representing when I click on an item, it puts it in this state. So this is where this logic comes into action. So if it finds that there's an item in the favorites dialog item, it should show this favorites dialog, which is here. And if I cancel, then this will nullify this, so it renders this again. So this is not part of our view model. This is part of the UI state that's here in this screen. So we made it here and by remember and so on. So this approach minimizes the parameters, minimizes nearly everything, and it stores everything in the view model here in the implementer of this one. So here we have the progress, which is mutable state, and mutable state, and mutable state list of. One other code. So again, so in this screen, going through its architecture, this is the UI section, which is on the same level of the adapters. And we have here the scenarios, which are, first of all, let's start with the entities. So we have here a GitHub repository entity, as mentioned in the requirements. It has an ID, a name, or whatever. And it has a metadata, which is the original GitHub DTO that comes from the server. So we keep it with us here. And we have these scenarios. We have this home screen scenarios. So we have the list all. This is the list all use case that we have seen in the requirements, and doing the same actions. And since this is Compose, we don't have a view model scope, so we are taking the scope. We are making the async calls here in the coroutine scope, and this is called in the launched effect, so that this happens in the initialization of the composition, the same way as if we are doing this in the our view model initialization, but with considering that this will repeat every time and this will persist. So anyway, in some implementation details. But anyway, now if you see in this screen, and this is the ports. So we have here the state ports that we need, the data sources, the progress, and repositories, and we have the data sources port that we need, which we need to get all repositories, and we need to get all favorites, because if you see this icon, so if I have any favorite, it should be marked as favorite. So if I go here and then get back here, this is loading again, and once it's finished loading, it can detect which were actually favorited from this. So we need to get all favorites and get all repositories. One other thing, which I think it's one of the less important things today. I know we took that long today, is that if usually the domain models needs to be immutable, which means that this GitHub repository model that we have declared, this one should be immutable. If you see val. So how will I manage to do this favoriting stuff? How will I need this? Now this one has an updated, this one has a favorite flag, right? So instead of controlling this from the home level, for each item here, since this item has its own view and its own communication with the data sources, so each item from those items deserves to be a feature by itself, like a component by itself. So if you look here, we have the home business logic and the home state port, the home data sources, and the home adapters. We also have the GitHub repository business logic, so that this GitHub repository is the item itself. So we have a GitHub repository port UI, which holds the UI for every. I'm just trying to zoom in. Yes. So this GitHub repository state is holding the state of each UI element, and it has things that's needed. And at that point, since this is holding the UI element, it can hold vars normally, which is favorite, like progress, like if there's an error. So this is the state UI state port, and we have the data sources state port, which have the methods of add to favorites, and this requires to add a GitHub repository to favorites or remove GitHub repository from favorites. And in our business logic, we have our use cases as agreed. This add to favorite use case and remove from favorites use case, and they start manipulating the UI state by modifying the UI parameters and then using the data sources port to get to execute the favorites and so on, and then getting back. So it's our business cases or our scenarios are manipulating the state, the UI port and the data sources port to finish the business. And now we have, this is the adapter for the UI state, which declares mutable states for our types. And this adapter implementation detail, this is not doesn't deserve to be a view model, since it is not scoped for the screen's life cycles. This can be a normal object, even if on Android normally this will be a normal object. So it takes its initialized upon initialization of the big screen, and it takes the GitHub repository domain object as a parameter to put it here in its own state, so it can be rendered later on. Same for data sources here. We are using the same data sources to start getting the data from and to the data sources layer. Actually, we are here saving and removing the same object. And the point is, if you see now, when you go to the screen and click here and click add to favorites, you are pushing to the data layer a GitHub repository object. But when you open the favorites, you will open a favorites repository object, not a GitHub repository object, since this is a feature and this is a different feature. And here comes the reason for the metadata part, or the part where we store the original POJO with us. So what happens here is, when we are clicking on add favorites or remove favorites, the add favorites is expecting a GitHub repository to give it to the data layer, and the data layer is expecting a GitHub repository data, the object that's declared in the data sources module. It's not the object that is data sources don't know about our domains in these cases. In this architecture, the data sources is a separate module, because these data sources will scope all of the native code and the expected code, the expected and actual stuff in it. So we have moved the data sources code outside, and we just inject it in the adapters. So now we here have the GitHub data. When we are retrieving the GitHub repository data, which is the data, the POJO that's coming from the server side, when we are parsing it to mapping it to our data, we put it in the metadata variable, we put the original object. And here, when we created this extension variable that returns this metadata object as the GitHub repository data, mapping it back, since just to make sure that we are safely casting it both ways in the same type, so that not everyone keeps casting in every place. So now when our favorites item here is click add, so it goes to this add to favorites and gives it a GitHub repository which is related to this our feature, and pass to it this GitHub repository data. It doesn't pass to it the GitHub repository. It doesn't pass to it this one. It passes to it this metadata. So that when the favorites, when we initialize the favorites feature, I'll just this favorite feature, if you go into the adapter and then starts to see the implementation of the data source, this all favorites data source, sorry. Do you see here? This favorites feature is expecting when it's that source. When I'm trying to fetch all favorites, I declare in the data sources port in my feature, I need a list of favorite repositories, which is the language that I understand. But internally here, what happens is that this function actually uses the get all favorites, which is in the data sources code, which knows the GitHub repository data. So actually, it takes the GitHub repository data and maps it to a favorite repositories. So what happened is this: when I'm using this implementation, if you see here, when I'm saving, when I'm caching the favorites, I'm caching the favorites as a GitHub repository data. So whether the GitHub repository data is the POJO of the server. So when I'm in the GitHub repository domain object, I give it a GitHub repository object, but it takes the POJO inside it to save it in this cache. And then when I load from favorites, which is a totally different domain on the mobile, totally different feature, and it starts to load, it takes this data and converts it to the favorites. So I don't care which parameters each feature will use. I have all the POJO with all of its parameters with me. So I save it in the data sources and I load it from data sources. And I can pass it around in the metadata. I hope this passed through, but if you didn't get this part well, so I can discuss it more on LinkedIn if there's any question or about this part. But anyway, so the favorites are nearly the same thing. So just the favorite screen is nearly the same thing. Just finishing the last part, which is about the GitHub repository item itself. So here, the GitHub repository, as said, we will have its own business logic. Now we have the initialization, which takes all the favorites to start. This is the GitHub repository item part, is to detect if it is one of the is favorited or not, and the add to favorites, which data source uses the port of that source for it to add favorites, remove from favorites. So this is scoped scenarios for the GitHub repository item, and we have the GitHub repository state, as I said, GitHub repository data sources, and we have the GitHub repository adapters, which is the state, mutable states, and data sources. I know that the project is somehow big, too many stuff to mention, too many things to mention, but at the end of the day, this is to showcase that we can, through Kotlin Multiplatform, Compose, and architecture that can isolate our code, like a hexagonal architecture, isolate our business logic and our important code, and also use UI composables in the adapters or in the UI logic. Now we are currently, all the project from its start to the end are all in the KMP common module, except for this package. All of this is totally functional from here to here. This is totally functional KMP code. No need for any native code except here. So I know that this is very big to grasp, in one session, but I tried as much as possible to showcase some ideas, some of the process, some comments about what Compose is actually into. And also, if you see here, the dependency injection in this architecture is very simple because we only have these data sources adapters that needs one dependency, and we have the state adapters, which also need one dependency. This one, which needs one dependency with this is the injected one here. So we usually have only two dependencies and one dependency when we are starting the composable. So we need to inject exactly three dependencies per screen. So think about it. Even if you need to make and if you need to work with a dependency injection framework, it won't be worth it. It won't be worth it in such an architecture, because as you see, like those are two classes beside each other, and everyone is nearly has no code at all. It's more about delegation. Like think about unit test for this class. Like most unit tests will come to the core package. Testing these classes will be meaningless, just for test coverage, to be frank. That's it from my side. I know I've took a lot, but any questions about what happened? Any thoughts?
Yeah, I am afraid that there are no questions. I'm not sure because it was too tough for them to grasp, or because it was you make it very easy, so there is nothing to ask about. Oh, here is a question. Okay, great. So Ahmed Shahata is asking, where can you find good articles, tutorials on creating a suitable architecture for our project, Android or KMP?
Well, I think it's about you need to first understand the different available architectures, different available options, and then you need to think about the problems for each project so that you can get the proper solution. It's similar to the design patterns. Like you know the Django 4 design patterns, but there is no book that will tell you you need 1 to 3 to make pattern 1 to 3. Yes, there are some, you know that this pattern solves this problem. So when you see this problem in a project, you apply this architecture. So as a first step, as you need to learn the design patterns and what problems do they tackle, you need to learn the different architecture patterns and what problems do they tackle. Like for example, this hexagonal architecture is selected in this project because the core of hexagonal architecture is about putting the code that cares in an isolated center, which is the port, and the code that doesn't care, put it as an adapter. Anything that needs to deal with this code comes in an adapter. So this is why it is selected for this KMP project, because we need the code for KMP to not depend on any native code outside it. So we have to maximize the code that cares, so that with KMP, which does not depend on any other native code, and we could achieve this through doing the steps that we have followed, so that each hexagon has in its core the KMP logic that does the business rules, and then comes Compose to help us in the UI to makes it possible to not depend on the native even for the UI. So you gain more parts of the code that doesn't need native code. So I don't have a direct article in my mind for this stuff, but I think if you going through one by one of these architectures, like I myself had made the sessions, but this was like my own thinking. I don't take myself as a standard to someone, but I believe it's more of learning the architecture patterns and understanding what problems do they solve, and at that point you will find yourself being able to use it at the correct time.
Okay, so we can have in one project three patterns: MVC, MVVM, and MVI.
These are GUI patterns. These are UI patterns. These are not architecture patterns. And the point is, if you're talking about I by myself doing a project, when I find a problem and there's a pattern to make it easier, I will do it. So if I find a problem that deserves to be handled with MVI or MVVM, I will do it. But life is not that straightforward because we don't work alone. We work in teams, and teams have different times, different kinds of experiences, and also sometimes selection of a pattern can be subjective. So some teams go for unifying a certain pattern across the project and take the trade-off of over-engineering at some parts and under-engineering or missing the pattern or having more problems at other parts, but for the sake of that all the team can do one thing well and they can handle it well. Especially because another part of it is that it's the problem is very similar in all the three patterns. Like we need to deliver some data to the UI. But if this data is coupled to each other, then let's move to an MVI. If this data is reactive in nature, if it's updating more of from the background than the user, then we need something like an MVVM or MVI if it's coupled. If this data is driven by the user, then MVP will be easier than MVVM. For example, you'll find yourself declaring many variables or states or observables and not using any of them except in the initialization. And all of your work is just calling methods as if you are calling the presenter. So again, like 50% of the problem is common, which is delivering the data to the UI, and this is the 50% that matters. The other 50% can be kept to how senior the team is. If the team has that talent that can decide and not complicate stuff, and it's like there's some teams of 3 or 4 people that are very senior, for example, so they don't need this kind of caring about consistency. Unlike a project which is managed by 4 or 5 squads or 10 squads, and they need to have one point of reviews. So at that point, it will be hell for the reviewer to start understanding each pattern. It's a trade-offs. Like, do we have any other questions? I don't know if I'm disconnected or. Anyways.
Yeah. So, for example, we can separate the splash screen and the login screen with and have a different pattern for them from the rest of the application, and we can have other pattern, for example, for the profile, because there are no UI interaction and UI updates.
Oh, by the way, in our KMP project, you define the pattern in the interface of the UI state port. If you wanted an MVVM pattern, you will declare for every UI element its own variable in the UI state port, so that when you implement it in the adapter, you will have multiple streams. Each stream is reflecting and it's composable for its UI place. If you want to work with an MVI, you will declare in your UI state port 2 streams instead of multiple variables, which will be states at the end. And these streams, one stream will put the UI state as a data class, and another stream will receive your intents or actions as a data class. So switching between those 2 patterns, for example, is as simple as changing the structure of the UI state port interface. It's as simple as that. It's not that complicated like we used to do with the view models and that stuff. The use cases are in the scenarios are the same. It's just instead of the use case updating multiple variables, each one alone, it will update the whole data class, for example. And we will observe on the intent stream inside our use cases port, because it's not actually use cases port. It's the code that matters. It's the logic, whether it's a presentation logic or a business logic. And that's why it's hexagonal. We are not here in clean architecture where we have divided our use case and repository and If you see, for example, we didn't mention anything about repositories. Although the data sources port plays the role of a repository pattern, but it's different. It's not that detailed. It's very flexible and cares about the code that matters, not about applying many rules to regulate the project, but it's just to the point for what matters. I think the code is on GitHub. Actually, this is an operational code. I've run it on Android. It runs also on iOS and also runs on the desktop app. And if you look into the project, the maximum longest method you'll find, it will be, aside from Compose, because Composable is different, around 6 or 7 lines. And this is including everything. So we always focus on what matters, and that's it. You start by very small snippets. And I didn't mention anything about testing, and testing is the easiest thing in such projects. Like, you even have many classes that doesn't have anything to test. Like you have the ports, they are just interfaces. Their implementers are nearly doing nothing. The data sources implementer, the adapter, is just delegating calls to data sources, and the IO implementer is just declaring those variables to be mutable state of, to be observed by the composable, which is an out-of-the-box feature given to us by Compose. It's to listen on the states automatically without our interference. So all of this code is not written by us anymore. So all what you have to test is this small business logic file or this logic file, which is controlling the UI state port and the data state port. So it's minimizing the efforts.
Okay, perfect. I believe Daria, she was asking about the resources and the code. You mentioned GitHub repository. So how
Yes.
they reach this repo and look at the code?
I put the repo in the presentation. I'll let me know where to share its link. It's in my profile on GitHub as well. It's called KMM/Compose 2024, something like that. You can search for my profile on GitHub, Ahmed Adel Ismail. Also, I'll share it on LinkedIn. I'll share this presentation with this video and the links on LinkedIn. I'll try to put it in the featured parts so that people can access that stuff. I know it's a lot to grasp in one session, but I hope this video can be a reference for someone later on in the future.
Yes, of course. Ahmed Shita, he asked again about how to solve the callback hell when you have multiple navigation actions per screen.
Actually, if you see how it was divided in this example, whatever navigation action you have, you declare it in your root composable of your screen as a function that will be triggered later in your navigation. So, for example, I have to navigate to screen 1 or navigate to screen 2 from my own screen, from screen 1 to screen 2 or screen 3. So I will declare 3 parameters, which are lambdas functions. And this parameter called on navigate to screen 1, and this is just a function. And I trigger it into navigation screen 1. I don't call the navigation host, for example. And if it needs any parameters, I declare this lambda that takes a parameter of the type that I need to give it to it. So I pass it to it. And the same for 2 and same for 3. And in the application part where I design the navigation, where I start injecting the view models for the composables and the navigations, the navigation host, instead of giving you the navigation host, I'll put in the parameter that takes this function, the code for the navigation host that triggers this screen. So from your internal composable, you don't know anything about navigation, you don't know anything about the navigation components. You just have to receive callbacks in the parent composable to trigger when you need to navigate. And the part where it handles the navigation across all the application, it just can see the navigation host, and it can do the implementation for navigating for you in each parameter. Like what we did in the login, we had a parameter called on success, and in the home we had a parameter called on favorites clicked. This parameter navigates to another screen. So it was injected in the application port, not giving a navigation host and doing whatever inside our composables. But I can't relate this question with the callback hell, like, because these are not callbacks. Like, does he mean like when you're waiting to something and gets a callback from? I don't know how to relate between this navigation actions and the callback hell port. I'm sorry, because callback hell is callback inside the callback inside the callback, and I don't think this is the case in our case, right?
Okay, I'm not sure that this is related to your question, but Ahmed Shita is asking again. But in some cases, we need a lot of navigations. For example,
I'm waiting for the example,
I
but I
have no idea.
understand. Okay, but even of how like you can group the navigations for a certain screen in a router, and then let this router navigate. Like for example, instead of me declaring, let's say that this screen will navigate to 15 destinations. So instead of declaring a 15 parameter in my composable, I can declare a router, and this router is responsible to take the navigation host and navigate to the 15 destinations, and take this router from my parent composable parameter. So still my parent composable doesn't know about the navigation host. I delegate this responsibility to the router. And this router is just a normal class that has these 15 operations, and it can be declared at the same place where we are declaring these navigation host or whatever. I'm trying to think loudly about solutions, but I mean is giving the navigation host to a composable and let it internally control the navigation host directly. It's not it's not the responsibility of this composable, and I don't think any composable would care about uh, navigation. It cares about rendering. It cares about UI state. It cares about calling back the data to update something, and usually this is done in some sort of effect. Anyway,
Okay,
so
Ahmed Shahata is saying thanks for clarification. And now we do have one last question from Abdurrahman Islam. He is asking challenges we have faced in architecture Kotlin, Swift code, Swift UI code in Kotlin multi-platform with native UIs.
no, what I'm displaying here is something like a POC. I didn't. It's like giving some ideas of what I know. I didn't go into real world big project with Swift because at the old days, for example, I remember there was a problem with suspended functions with Swift. And as far as I know, they keep fixing these problems. So I didn't get that much of involvement with Swift UI, and I believe based on what was introduced today, like if you have any problem, you can just make it as a native implementation in the problem. But you don't need to you shouldn't need this in the business logic. You shouldn't need this in the presentation logic because both are, as you see, it's pure Kotlin code, which is just updating some variables and doing something. If you have problem with the UI rendering part with Swift UI versus Compose, you can inject this, you can do this in the native code for this part. But the big part that matters is working fine. And by the way, this project is working on iOS device and it's working fine as well. I'm not saying that this is the biggest project, but of course, in professional life, things get much complicated than that. So I didn't still have chance to go through this in real life with complicated projects. But so far, based on what we see now, we have lots of percentage of code that can be covered in KMM. Even if you have problems with UI, you can still the presentation logic at least and the business logic can all be implemented in KMP without any problems, without conflicts with the native code.
Okay, perfect. Abdurrahman Shahata is thanking you for the clarification. I believe he did get the answer that he was looking for.
Okay.
Okay, any other question before we end this session? I believe they asked all the questions that they need, and it was a very pleasantful presentation. and thank you for your time. You did a very great effort in creating this demo app and also in clarifying this demo app. So thank you on behalf of the community, and hope to see you again in another contribution and in another new session and another new topic. I believe yes, you have some still in your pocket, and let's just surprise the community with them.
Thank you, and really sorry for this long and intensive thing. I tried as much as possible to compact as much stuff as possible, but I know it's hard to grasp in one session. So my apologies if this was stressful or something. And I'm available on LinkedIn for any questions, for any or for any feedback. You're more than welcome.
Okay, perfect. So you know Ahmed Adel Ismail. You can just ping him at any time. And as he mentioned, he is going to share the link of the video with the slides, with the link for the GitHub people, for those who want to look at the. Thank you again, Ahmed, and have a great day. And it was a very pleasantful and very insightful meeting, and I believe we did all got something out of it. If we couldn't manage to grasp all the knowledge, at least we grasped enough so to contribute our knowledge.
Thank you. Thank you.
Okay, perfect. Thank you all, and have a good day.